August 24, 2020. Hello everyone, this is the channel of New York City News, and now here is the latest health feature today. Hitting the nail on the head, overcoming therapeutic resistance in lung cancer. A protein highly expressed in lung cancer cells drives resistance to targeted therapies, report researchers at the Medical University of South Carolina in the Journal of Thoracic and Cardiovascular Surgery. In preclinical experiments, the researchers showed that inhibiting the protein caused the death of non-small cell lung cancer cells that had become resistant to therapy. The Musk team was led by Chadwick E. Dendlinger, MD, who was then surgical director of the lung transplant program at Musk Health, and Musk Hollings Cancer Center researcher Robert Gemmell, Ph.D., who is a professor emeritus in the Department of Medicine. Dendlinger is now division chief of thoracic surgery at Indiana University but continues his collaboration with Gemmell. Lung cancer accounts for a quarter of all cancer deaths, and non-small cell lung cancer makes up 84% of all lung cancer cases. Targeted therapies can be effective for a time against selected lung cancers, but resistance to these therapies soon develops. A cancer cell is like a small factory with many moving parts working towards one common goal: survival and reproduction of the tumor at the expense of the patient. A type of targeted drug, called a tyrosine kinase inhibitor, or TKI, works by inhibiting a specific, vital piece of machinery within the cell factory on which it is dependent. However, the factory has many fail-safes in place and can quickly rely on another piece of cellular machinery to continue to grow and survive, even in the presence of the TKI. The ability of a cancer cell to adapt to a new strategy to survive is called genetic resistance. When researchers developed TKIs for the treatment of cancers such as non-small cell lung adenocarcinoma, NSCLC, they had hoped they would become the magic bullet to treat the disease successfully. One of the benefits of TKIs is that they're much less toxic and are fairly beneficial. We see a dramatic response and the tumors shrink, said Dendlinger. But a limitation is that these effects don't last very long before the cancer cells evolve new techniques to become resistant to the drug. Due to such resistance, the survival outcomes for patients receiving TKIs are no better than those for patients receiving conventional chemotherapy. Consequently, the need to find treatments that can overcome that resistance is urgent. Gemmell's group, which includes Cecile Nazar, Ph.D., Anastasios Daimou, M.D., and a summer undergraduate, Rose Pogano, recently linked drug resistance in lung cancers to the expression of a cell surface co-receptor neuropilin-2, NRP2. Gemmell received pilot project funds from the South Carolina Clinical and Translational Research Institute for his work with NRP2. One of the earliest things we discovered was that the NRP2 variant protein, NRP2B, dramatically increased in lung cancer patients who became resistant to therapy, remarked Gemmell. This gave us the first clue that it becomes upregulated in resistant tumors. The investigators then performed a series of experiments in which they knocked down NRP2B from lung cancer cell lines that were capable of developing TKI resistance. When we knock down NRP2B, we lose the surviving drug-tolerant cells, said Gemmell. And by reducing that population, we believe we will reduce the ability of the tumor to develop genetic resistance. Next, they explored how NRP2B could be contributing to drug resistance in lung cancer cells. They started with GSK3, a molecule that's involved in many different activities within the cell and has been reported previously to interact with NRP2B during neuronal development. The investigators performed experiments to determine whether NRP2B interacts with GSKB. You can think about GSKB as a hammer, said Gemmell. And this hammer has the job of hammering many different nails that are present in the cell. NRP2B is like the hand of the carpenter that directs that hammer to particular nails. NRP2B is using GSKB as a hammer to drive very specific nails, and we want to stop that because those nails are driving tumor progression. To better understand the specific nails that NRP2B and GSKB are driving in lung cancer, the investigators performed experiments in which they measured how well lung cancer cells can migrate and survive in the presence of TKIs and the absence of these two players. With these experiments, they found that NRP2B needs GSKB to promote cancer cell migration, an essential step in cancer progression, and drug resistance. Now that the investigators have identified a mechanism by which cancer cells are becoming resistant to treatment, their next step will involve developing inhibitors. More specifically, they will try to develop inhibitors that interfere with the carpenter, NRP2, grabbing the hammer, GSKEB. Importantly, these inhibitors should not interfere with other functions of GSKEB, which will reduce potentially harmful off-target effects in a healthy cell, said Denelinger. Currently, the team is working to test the toxicity and effectiveness of prototype drugs that could specifically disrupt the interaction between GSKEB and NRP2B. They are collaborating on this work with Musk College of Pharmacy researchers Patrick M. Waster, Ph.D., Chair of the Department of Drug Discovery and Biomedical Sciences, and Associate Professor Yuri K. Peterson, Ph.D. Ultimately we could find a way to improve therapy for cancer patients, said Denelinger. A therapy that could extend the influence of TKIs and potentially reduce metastatic spread and extend the lives of patients. Hello everyone, this is the channel of New York City News, and now here is the last health feature today.